How do I solve the first one? The angle addition or subtraction ones?
Yeah.
So those stem from... what am I? It's not a straight line. But let's just... I don't have a great... All right, it's just called tip to tail, or tail to tip, however you want to say it. When you're adding visually, so for both of these, we're supposed to do a plus b and a minus b, right? So a plus b, none of this is here. So pretend like that's gone for just a second. A plus b is you travel all the way out on A. And then you just add length b onto that tail. So you take this b and add it onto the tail. So that's going to look something like this. So I just moved this and added it right on the end of that tail. And where those point to is the point of your new vector. So basically it just tells you where your point is, and then you draw the vector to that point. So this is A. I should probably make this a little bigger. Plus B. It is A up A over B. Well, A minus B, if B in the positive direction goes like this, B in the negative direction is going to go that direction. So A minus B is going to be that point right there, and we just draw the line going to it. Same thing is, you can kind of see it on here. I went up A, and then I tacked on B onto it. So I added B. I don't really have the point up there, but that would be my plus B right there. All right, a minus B. If this is plus B, minus B would go in the complete opposite direction down there. Does that make more sense?
Yeah.
Okay. Yeah, it's just visually you could see it tacked on to the end of the other one. So as a very quick example, maybe something completely different that wasn't on here to see if it really makes sense. Let's say I have to do B minus A. If I have to do B minus A, you travel along positive B. So I travel along positive B like this, and I'd be there. Now to subtract A, positive A would go up here. Well, negative A is going to go in complete opposite direction, so it would go down. It went up 1, 2, 3, 4, 5, so we'd have to go down 5 of these tick marks. So it'd be down here. You'd put a point there, and that vector right here would actually be the vector of the two things added together. Other questions? Questions going once? Twice. This stuff is going to be reused a lot. All right, if there's no questions for me, then we will continue on. Today we're going to talk about operation rules for vector. The first thing we're going to talk about is something called a scalar product. A scalar product just makes your vector either longer, shorter, or reverses its direction or several of the items above. So for a scalar multiplication, it would look something like, let's get this down. It'd have something like K times A. It could look something like that, which would be the exact same thing as this. Which is equal to putting it on the inside. K times A sub 1, comma, K times A sub 2. So a number multiplied on the outside, making your vector longer, shorter, or reversing directions. The way you're going to get those numbers to be exact is you're just going to distribute that K into both of your components of your vector. And we'll do an example down below in just a second. All right, vector sum or addition. Well, visually, it was just like what we did, Leo. That's what we did. We just added two vectors together. That's all we're doing. That is a visual representation of adding two vectors together. Now, sometimes it's a lot easier to use it just the algebra form so you don't have to draw your vectors and see what your tip to tail looks like. So in these cases, we'd be doing a vector sum or a difference. So in this case, did I do A plus B? Yeah. If I had to do vector A plus vector B, well, that could be also written as A sub 1 comma A sub 2 plus B sub 1 B sub 2. Those say the exact same thing. If you need to do your vector addition or subtraction, you're just going to take your first two elements, add them. And then take your next two elements and add them. In these cases, it's my horizontal component that comes first, or my x value. So we're going to have a brand new vector that's going to look like A sub 1 plus B sub 1, comma, my second component, which would be B sub, let's put it in the right order, A sub 2 plus B sub 2, and the resulting would be a brand new vector. Bless you.
Thank you.
Addition's really not a big deal. If you do A sub 1 plus B sub 1 or B sub 1 plus A sub 1, you should come up with the exact same answer. However, if you're ever subtracting, if I tell you to do A minus B, make sure your A component comes first. So you have A sub 1 minus your B component comes second. So that would be A sub 1 minus B sub 1, comma, A sub 2 minus B sub 2. If you do it out of order, you come up with the wrong vector. Dot product looks like multiplication, but it is not multiplication. It looks like A times B, but it is the dot product of A and B. This is one of those times I'm going to tell you a lot of people are going to get this wrong on the test because you're not going to take proper notes, and you're not going to study your notes, and several of you are still going to get this wrong. It is not a multiplication. It is not a multiplication, so it doesn't work the same way as it does for addition. Because a lot of people in the test are going to do A sub 1 times B sub 1, comma, A sub 1, A sub 2 times B sub 2. It doesn't work that way. In fact, this is going to result in just a number. This is just going to be equal to A sub 1 times B sub 1 plus A sub 2 times B sub 2. Your dot product, in fact, is used to compare two vectors. It's not to change the vectors, it is used to compare vectors. So its result should not be a new vector. Once again, this is going to be a big mistake on the tests. It's a super easy problem, but if you treat it like A plus B and A minus B, then you get it 100% wrong. All right, dot product results in just a number. It won't be a new vector. Scalar multiplication, new vector. Vector sum or difference, new vector. Dot product will just be a number. It'll just be a number comparing the two vectors. Yeah?
Are you going to say, like, find the dot product of this?
I might just say, do A. It'll look like A times B, but you need to know that this always means dot product with vectors. There's no real way to multiply vectors. You usually don't do that. Okay? Let's do some examples. So if you look here, see that W times Z in the bottom right-hand corner? That's a dot product. I'm not going to specifically say you need to find the dot product. You just need to read that and go, that's not multiplication with vectors. That is, in fact, a dot product. But let's do W minus Z first. So W minus Z is really just saying take the components of W, which are negative 3 and 2, and subtract away the components of Z, which would be 5 minus 1. Well, this should result in a brand new vector because that tip to tail. We could visually see it. In this case, we're going to take the elements from W first. So that would be negative 3. Minus the part from Z, which would be 5. Comma, my element from Z is that 2. Minus my element from Z would be that negative 1. Don't mess up the subtraction. I am now subtracting a negative number, which makes it positive. So our brand new vector is going to be negative 8. 2 minus a negative 1 is actually plus, so that's negative 8. 3. This would be the exact same result if you graph this one and do that tip-to-tail method we started off with today, part of our lesson. Our next one is a scalar multiplication. Scalar multiplication creates a brand new vector. So what we're really doing is negative 8 times the components of Z. So that would be 5, comma, negative 1. Well, a scalar multiplication, it works just like distributing, where we're going to have negative 8 times that 5, comma, that negative 8 times that negative 1. Well, that's just going to be negative 40, comma, a positive 8. All right, that bottom left-hand one says 3w times 4z. The first thing you need to figure out is what 3 times w is and what 4 times... All right, so 3 times w. 3 times w. W is usually negative 3, 2. So let's just do that first. We can do that as side work. Okay, 3w is going to equal 3 times a negative 3, which is negative 9, comma, 3 times 2, which is 6. 4z is just going to be 4 times the elements of z. 4 times 5 is 20. Comma, 4 times a negative 1 is going to be a negative 4. So now when I do 3w plus 4z, we're adding those two vectors. So that's negative 9, comma 6 plus 20 minus 4. Well, we add the horizontal and then we add the vertical components. So that's going to equal a negative 9 plus 20, comma 6 plus a negative 4, which is going to result in 11, comma 2. Once again, hey, these aren't too hard. Normally people don't miss many of these on the test. These will be on the test. Just ones just look just like this. I'll give you a w, I'll give you an x, and say do 3 times x. Do x plus y or something like that. So these will be on the test. These shouldn't be super hard points. The one that people are going to mess up on is this one. They're going to go, oh, it's multiplication. I'm going to take my horizontal element, so I'll do negative 3 times 5, and then it'll be comma 2 times negative 1, and then I'll have my answer. That is not what it's asking for. It's asking for the dot product. The dot product will always be a single number. So when I'm doing w times z like this, this is going to result in my horizontal components being multiplied. So that's going to be negative 3 times 5 plus my vertical elements, which are that 2 and negative 1. So it'd be 2 times a negative 1, which is going to equal negative 15 minus 2, which is just going to equal a negative 17. That is it. That is correct. It's not going to result in a vector. Whether you're someone that actually studies your notes or not, you should probably have a note on it that says, don't miss this. All right, like I said, you shouldn't miss too many of these. These should be just simple kind of multiplications, additions, type of problems. This one gets a little more difficult. It says find the magnitude and direction angle of the resultant. The resultant is what happens when you add the two vectors together. So resultant means add two vectors together, or just add the two vectors. I should probably just put add the two vectors. Well, if we're doing stuff to the resultant, it's probably a good idea to find your resultant first. So I want to add this vector plus this vector. We can do that two methods. One way is a lot better than the other, especially when you have a graph. One way is, just like we looked at the homework, I could do tip to tail as long as you did it perfectly. So we could say, well, if I travel up this one and tack on that on top of it, I'm not going to do the actual, because I think the other math is, but it's going to be somewhere up here. My vector is going to be somewhere up here. You could do it 100% precise. You could say, well, this is up 1, 2, 3, 4, 5, 6 over 3, and you could go up 6 over 3 and get that exact same thing. That is the visual representation. That is that tip to tail. What I would prefer, because that makes a lot of mistakes, is actually look for the component form of both these vectors. The component form is, what is that x and y value here? Well, the x and y value here are 2, 6. So that point right there is 2, 6. Remember, we use those carets for our vectors. Where our other vector terminates is that point right there. Well, that's -6, +2.
The top one's supposed to be 3.
Did I say it? Did I even say it wrong? Yeah, it should be 3. You are correct, sir. All right, so we have 3, 6, and we have -6, 2. Now, to add the two vectors, we just do what we just learned, that anytime you have two vectors that you need to add, you just add the horizontal and the vertical components. So to get my resultant, we're just going to take one of the vectors. Let's take -6, 2, and add the other vector, which is 3, 6. Well, that's just going to be -6 plus 3, which will give me a -3. And then we'll have 2 plus 6, which is going to give me 8. My new vector is at the point -3, 8. So let's put it on here. -3, 8. Uh-oh, we're off, but that's going to be okay. -3, 8 would be about up here. And when I did that tip to tail method, that's about exactly where we had it. So you can use it visually. Do your tip to tail by copying that down. Make sure you have the angles right. I prefer the algebra, so you don't have to, you're not making mistakes visually. Well, I don't even care about these other two now, because it says find the magnitude and the direction angle of the resultant. We're supposed to find the magnitude and the directional angle of the resultant. Did I have room to draw more pictures in there? Yeah, I did. So I'm just going to redraw what's important here really quick. So I'm going to draw that angle right here. So that angle I just drew, that vector, I should say, you aren't going to let me do that, are you? No, you're not. Close enough. So that's going to be my vector. That's not close enough. That angers me. There. There's my vector. There's that vector we just drew. And I'm going to turn it into a right triangle. I'm going to turn it into a right triangle where my x value is -3, so this is -3 down here, and the height of it is up 8. All right, the first thing I'm going to do is find the magnitude. And what I want you to remember from magnitude is just length. What is the length of this line? What is the length of that particular line? So that is my magnitude. What is the length of that line? Well, it's a triangle. It's a triangle that's right. And so I could just use a squared plus b squared equals c squared. So if that length is r, we would just say something like r squared equals 8 squared. I guess we can do plus. A squared plus b squared negative 3 squared. Which, if you remember, the formula is just the square root of 8 squared plus negative 3 squared. And it has to be positive. Well, a squared is 64. 3 squared becomes a positive 9. So we're just going to have our magnitude equals the square root of 73. And I'm not going to simplify it any further than that, but that is my magnitude. That is the magnitude. All right, directional angle. Our directional angle is this angle right here. It is this angle right here. So it is, I'm going to color it in, I guess, red. That theta right there is the angle I'm actually looking for. That angle right there is the angle I'm looking for. However, I need to use kind of a reference type angle, and that's going to be the angle that's in my triangle. That is my beta. I'm going to find my beta, which will get me my theta. Once again, I'm going to solve for this beta, but I need to know that my directional angle is actually the one that goes from the origin and terminates here. We will always find this one, but we have to use that to find our theta. All right, to find my beta, we're going to use tangent. And the tangent of beta, tangent is TOA, which is opposite over adjacent, which is going to be 8 over negative 3. A little hint, your y value is always going to be on top. Tangent of beta is always going to equal y over your x value. All right, I can't solve for tangent, so we have to take the tan inverse of both sides, and beta is going to equal the tan inverse of negative 8 over 3. And I got out about negative 58 degrees. Can anyone confirm that? Or did I?
Negative 69. Yes, no, I got it.
Oh, is it negative 69?
Yeah, so I got it.
All right, negative 69 degrees. That is not the angle I'm looking for, though. I'm looking for that red theta. The red theta is your directional angle. It always goes from that initial side, just like with our unit circle, where we always go from 0 degrees all the way around. So I'm looking for this red theta. Well, that means to get my theta, we just have to do 180 minus that's 69 degrees. So anytime we end up with a negative, we're usually subtracting it. It's either it's 360 or it's 180. Just look at where you're working on. All right, and that's going to come out to 111 degrees. All right, questions on that? I don't know what it is about this type of problem, but people mess this up all the time on the test. They know how to find magnitude, they know how to find the directional angle, but But for some reason, adding that resultant in there is enough to throw you off your game. Just find your resultant, and then just realize I'm just asking for your magnitude and your directional angle like you did on your homework over and over and over again. All right. The last thing we're going to talk about is the angle between vectors. To get the angle between vectors, if A and B are non-zero vectors and alpha is the angle between them, then cosine of alpha is going to equal A times B, but it's not really A times B. That is going to be your dot product. Over, and note those absolute value bars, those are both magnitudes. So you need to take the dot product of the two vectors, and you also have to find the magnitude of vector A, the magnitude of vector B, and you're going to multiply those two things together. It is just a formula you're going to need to know. So this is just one you have to have memorized. All right, once again, angle between vectors, you have to know this formula. It has to be memorized. All right, the angle between vectors is very useful in giving us information about the vectors without even plotting either one of them. Now, in pre-calculus, we're just going to treat this as a number that we find. When you get to calculus, and when you talk about higher level physics, then you actually apply these. All right, the only real reason we're doing this, coming up with our number and deciding whether it's parallel, if it's perpendicular, or neither. So we'll go to these three different situations that are key. If A and B have the same direction, the angle between them is 0 degrees. That means they're going in the exact same directions. They're parallel. If A and B are going in opposite directions, the angle between them is 180. Once again, that would also be parallel. So both of these are going to be cases where our line is parallel. If A and B are perpendicular, the angle between them is 90 degrees. Thus, your cosine of alpha is going to equal 0. We can care less about this and more about what results in these. So your big thing are 0 and 180 mean your two lines are parallel. 90 degrees means they're perpendicular. So if you look at the first problem we have, we are supposed to find the angle between the two vectors, and we're supposed to decide if they are parallel, perpendicular, or neither. Parallel, you're looking for 0 and 180. Perpendicular, you're looking for 90 degrees. If it's anything else, it's neither. All right, so we have to find the angle between each pair of vectors. We need two bits of information. We need the magnitudes to multiply, and I need to know the dot product of those two things. So let's work on getting our magnitudes first. Just remember, magnitudes are just the distance of that hypotenuse. So if you need to, draw the point -3, 2 to recognize that it's just a squared plus b squared equals c squared. In this case, when I'm looking for my magnitude of we'll do this vector first, magnitude of -3, 2. Absolute value bars always mean find the magnitude of it. It's just going to equal the square root of your a value, so -3 squared. A squared plus b squared equals c squared, so it would be plus that 2 squared. -3 squared is a positive 9. Plus 2 squared is going to be 4. This is just going to equal the square root of 13. All right, let's find the magnitude of 4, 5, the vector 4, 5. Same exact thing. It's just our horizontal component squared, so that's 4 squared, plus our vertical, which is 5, 5 squared. 5 squared is 29. Plus 16, that's just going to be the square root of 41. All right, those are my magnitudes. Let's find our dot product. I'll put my dot product right below it. the dot product of vector 3, negative 3, 2, and 4, comma 5 is going to equal my horizontal components multiplied. So that's going to be negative 3 times 4 plus 2 times 5. It will result in just one number. All right, negative 3, negative 12, 10, so that's going to be a negative 2. All right, our angle between formula is cosine alpha equals the dot product divided by the magnitudes multiplied. So we are going to have cosine of alpha equals the dot product, which is negative 2, over my two magnitudes being multiplied, so that's square root of 13, times the square root of 41. Since I don't care what cosine alpha is, I care what alpha equals. We're going to do alpha equals the cosine inverse of negative 2 over the square root of, you can either type in square root of 13 times square root of 41, or you can type in, what is that, 435? 13 times 41. 433 times the square root of 4. 533. Alpha should be about, unless I had a mistake on my calculator on this one, about 94.97 degrees, which would be about 95.0 degrees. Is that correct? It's about 95%. Okay. We're supposed to also say, is it parallel, orthogonal, which is the same thing as perpendicular, or neither. In order for it to be parallel, it needs to be 0 or 180. In order for them to be perpendicular, it needs to be exactly 90 degrees. It's neither one of those, so it's neither. Not parallel or perpendicular, it is neither. All right, that covers today's lesson. Let's talk about the test really quick. People generally do well on these, minus this one. Then they lose a hefty 4 points because they don't know what dot product means. Don't lose 4 points because you just can't look back at your notes because they're in your notes. Most people know at the end of this how to do magnitude and how to do directional angle. But for some reason, they get really messed up when I ask for the resultant and then doing the exact same material. Picture stuff in your head, draw pictures on these. These are just straight lines coming from the origin. For this one, most people forget to take the cosine inverse of both sides, and they do cosine alpha equals, and they give me that value. You need to take the cosine inverse so I can get that angle so you can decide if it's parallel, perpendicular, or neither. All right, questions for me?